Hello. Today we will talk about strings in StringBuilder. So before we jump into any code or anything like that, I'm just gonna go ahead and show you this little, image over here. And for this image, what I'm going to do is I'm going to explain the difference between primitive types, which are ints and things like that, and then reference types, which are strings. You can think of them as basically two different types of data types. So as you know, there are multiple types of data types. However, we also have a distinction between those data types. So we have primitives, and primitives are basically they are stored in memory how the person codes it, right? So if I say, for example, int a is equal to 15, int b is equal to 10, well, if I go into my laptop's memory and find where int a is stored, and if I somehow open it up physically, I will see 15 where int a is stored, and likewise I will see 10 where int b is stored, right? And if I have this operation that says int a is equal to int b, well, now both a and b, their respective memory locations, will each contain the number, or the int to say specifically, 10. And that's not the case, however, for what we call reference types, okay? And you can understand that in the name. Here, they're primitive, right? So it's doing exactly what it should, primitively. It's storing the value within the memory location. Here, there's a reference. If you look at this little arrow over here, this is pointing to the actual memory location. So here, let's say we have C1, okay? So C1 is any string that we say, right? And that's the string itself, like the actual C1 variable is stored right here in memory, right? But the string value that I hold, for example, hello, that is actually pointing here. Hello is stored in this memory location. And then this arrow connects C1 and the memory location for the actual string value of hello. So this arrow is actually the one that's doing the linking. Over here, there's no need for a link because it's all stored in one area. And likewise, C2, if I have the variable C2 over here and the string hi over here, this is going to be pointing to hi, this is pointing to hello. So that's where the name reference comes, as the arrow is referencing another memory location, right? But if I write this this code right here, C1 is equal to C2, well, instead of both of them, like another circle of this size being created here and C1 pointing to that circle, instead what actually happens is we have C1's reference arrow point straight down to the original circle of C2. So you see that in this case, you don't duplicate the memory location that stores the original string value. Instead, you just change where the reference is going or pointing to, right? And so technically, when you write some code like C1 is equal to C2, right, or string 1 is equal to string 2, in reality, what you're doing is you're just copying a reference of that original value and assigning it to this memory location, right? So over here we see that, okay, we have actually changed the memory location of int a, right? So that way I cannot ever go back to int a is equal to 15 unless I write that code explicitly, right? However, this hello still exists in memory. However, this CL is just not pointing there. And that's basically the biggest difference between primitives and reference types. So now that we understand the difference between primitives and reference types, you also may understand the fact that strings and other reference types are technically immutable. So immutable, if we go down here to our file, and we'll just write a definition for immutable so that we can keep this right here. So immutable basically means, right, that you cannot mutate it, right? So it basically means you cannot change the value, right? And we can see that strings are immutable because, again, if we reference back to our little photo or image, we can see that the string reference is the thing that's changing, but the string itself isn't really changing. Whereas if you look at ints, which are mutable, you can see that the memory location changed from 15 to 10, and there's no evidence of the fact that it was ever equal to 15 int a, for example, right? So strings are immutable, right? Which in some cases is useful, but in other cases it's not, right? And that solely depends on the reason of your code, right? If I'm building, let's say, a hangman, let's say I'm making like a hangman game, right? For example, well, if I have the word, let's see, octopus, or not octopus, let's keep something simple, right? With a double letter, so hello, right? If I have the word hello, right, and the user or player 2 picks the letter L, well, I'm gonna for loop through this word, right? And then, okay, I see an L, so I'm going to delete it and then replace it with a dash, for example. I see another L, replace it with a dash. That way, when the person says L again, I'm going to be like, okay, there are no more L's, right? Similarly, that's why, like, I want to have the potential, like the capability to mutate a string. However, you can't really do that to a string unless I create a new string every single time, which can be tedious, right? Because you don't know how many, like, maybe this time I pick the word hello, but what if next time I pick something big like tropical, right? Or something even larger than that, right? I, as the coder, don't know what the word is going to be. So we want to have access to basically a string that's mutable. And that's where the idea of StringBuilder comes into play. So StringBuilder is basically kind of like what it sounds, string builder. So it can build a string. However, string builders, again, notice the capital S and the capital B, string builders are mutable objects, right? So this means that I can manipulate string builders however I want, right? And let's go ahead to our Hello World Java file and let's see an example, right? Because examples are the best way to really understand these things. I'm just basically going to set up how to, write a string builder object. And the way that you do that is pretty simple. All you start off with is capital S string builder, right? And as it turns blue, Java understands what it is. And string builder, and then you can name it whatever. I'm going to be naming mine SB because string builder, capital B, is going to be equal to new string builder. So it's kind of like setting up a scanner object, and then our parentheses, and then we can end that with a semicolon, right? And so string builder has a bunch of methods that you can apply it to, right? So for example, I can add here, let me do this, right? So I'm going to have a print statement right here that basically confirms the fact that I have an empty string builder. So I'm just going to print out the string builder variable, right? And it should literally have nothing. And the way that I know that it works is after this, I'm going to have another print statement that just says like, okay, done, right? And so that way I know that it legitimately works. And I'm going to run this code. And let's see. Okay, right here, yeah. So we can see that we have this blank space right above done, which means that the string builder is a blank, is just a blank at this point, right? But I can apply methods to string builder, for example. So I'll take our string builder object that we've created, SB, right? And then I can add a method called append, right? So in English, append basically means like add on to the end, right? So in this case, that's exactly what we'll be doing, right? String builder dot append, and so it's basically say, hey, take our string builder, at the back of it, append something, right? And then in this append area, I can put in a string, right? In here, I can write hello, right? That will work because if I have another print statement of our string builder, well, now it should print out hello. And let's go ahead and test that so we know how our string builder is working. And yeah, so first, when our string builder is empty, we have this blank line, then we have done, and then we have hello. So now that our string builder holds the string hello. Now what I can do is I can go ahead and I can delete stuff, right? So I can have sb.remove, and I think it's actually delete. Yeah, there we go. And then I can delete index values, so I can give it delete from I can delete from 0 to 1, right? So that's going to delete the first letter of this string builder. And then let's go ahead and paste what our string builder will look like next. I'm going to paste that. Let's go ahead and see how the outcome is. And here we have it. Empty, done, hello, and then we have deleted the H, which is hello. So as you can see, this is kind of useful, right? We can manipulate strings in whatever way we want, right? So for example, if you're making like for example, with my other example, a hangman game, right? So every time a person guesses the letter, you can have a for loop, and if it matches, right? Like if the person guesses L and there's an L in the word or the string that you have, set as the secret one, you can just use a string builder and then remove the letter, right? So in string builder, instead of just having hello, right, what I can do is I can append actual strings in here. So instead of writing hello, what I can do is I can have like string 8 or string 1 is equal to hi, right? And then instead of having dot append hello, I can just have dot append 1, right? And again, it'll be the same idea, and it will end with I since we got rid of the H. So go up, yeah, so blank, done, hi, and then just I over here. Now, the cool thing about string builders is that you don't have to restart with a string, right? Let's say I have a string over here. I'm going to make it string password is going to be equal to, ooga booga, for example, right? Very, very dumb password, but it is what it is. And I have, instead of having a blank string builder, what I can do is I can take this code over here, right? I can cut it, and then I can paste it right after here. And then in these parentheses over here, right? Instead of keeping them blank, I can put in password, right? So what it's going to do is it's going to have this string builder that contains the password within string builder, right? Then I can do whatever I want, right? So I can have sb dot append, and then I can put out a string like this is a dumb password, and then I can just hit that, and then it should append that value. Now I want to show that string builders will not, messing with the string builder will not mess with the actual string, right? So I'm going to have a string builder printout. So I'm going to copy and paste this code right here. Control C, Control V, and then I'm going to actually print out the password, our original string, right? And let's go ahead and see the output of that. So we're going to see right here. So first we have Ooga Booga, which is our brand new string builder. Then we have the append method working. Ooga Booga, this is a dumb password. And then finally we print out password, which is the original string. And you can see that the original string has not changed. It is still Ooga Booga. There's no appended value of this is a dumb password, right? And basically, this is just a string builder object. Now, what I can do, one last thing, is I can have a for loop that basically goes through every single letter in the string builder. But I will save that idea for the next video. since this video was just kind of an introduction to string builders and the difference between primitives and reference types. Thank you for watching.